Well, good afternoon, everyone, or whatever time it is you're watching. If you're watching this later, hopefully you have been able to join me, and I am aware that I managed to schedule this on a bank holiday. Obviously, nobody's used to having bank holidays on a Friday, so I do apologise if that's meant you've not been able to catch this live. But if you are here with me live, then thank you very much for joining me. Obviously, it's just an hour, so hopefully you'll be able to enjoy the time that we've got together, and that we can learn something in that time. So we've been looking into algorithms and all the different ideas behind those. Now, today's lesson, we're going to be looking particularly at trace tables. So we're looking at trace tables, and we're thinking about looking at simple algorithms to try and work out how those trace tables work, what their purpose is, where any errors have occurred, how to fix them. Okay, so a trace table is something that you will need to know how to use, because in the exam there will be at least one trace table. I've not seen an exam yet that hasn't included a trace table, or two or three, maybe even more than that. They expect you to know how to use a trace table and complete them. Okay, so with that in mind, I've got a little task for you in the chat to talk about. So in the chat, can you explain one of the following points in your own words? There are 5 things there. You can pick one of them. I know we've not got many people watching live, but I'm hoping that that number goes up quite quickly. So yes, in your own words, write in the chat, or in Tremor Homework if you've not been able to access the chat for whatever reason. Could you write one of those points in your own words? I'll give you not too long. I'll give you just like a minute, just over a minute. Right, so only a couple of people actually responded to my question. Joe, in response to your question, I did mention at the very beginning of the lesson that I apologise for having scheduled this on a bank holiday. I completely forgot that we were having a bank holiday on a Friday, because that's very rare. I've never had a bank holiday on a Friday before, and so I had just scheduled it as I normally would. So I'm hoping the fact that I had already scheduled it, by the time I realised that it was a bank holiday today and that I had scheduled a lesson, it was probably too late to reschedule, because it would have confused a lot of you. So I just kept this lesson going, and if you've not managed to come live, then you'll just have to catch up later. Okay, so a couple of you have talked about space efficiency, talking about time efficiency. Yeah, so space efficiency is about how much code you are using. So about having fewer lines of code. your time efficiency is about taking less time to process that code, as Fraser has mentioned. So the amount of time it takes to run your code, if it runs really quickly, then that is time efficient. If it runs slower, then it's not very time efficient. Okay, so nobody mentioned about syntax, runtime, and logic error, so I'm just going to quickly go over those three ideas. So syntax errors are, so I'm hoping you remember this from when we did our rubber duck debugging lesson. Syntax errors are where if you make mistakes in writing the correct programming language, so you've written a typo, or you've forgotten to have a speech mark, or a bracket, or a double equal sign, that kind of thing. So when you try running the program, the computer will tell you there's something wrong because it cannot understand the language you have used. So a syntax error is, the word syntax means the language of something, and so a computer gives you a syntax error if it doesn't understand the language you've used. A runtime error is when a computer tries to do something that is impossible. So it might divide by 0, it might try and open a file that doesn't exist. Robust computer code will make sure that these don't happen, okay? And then our third kind of error is our logic error, which are the hardest errors to spot. This is when the program works perfectly, but it doesn't give the answer that you are expecting. So the programmer has made a mistake in the way that program should work. Now, when it comes to trace tables, what is a trace table? I'm sure some of you might be asking. A trace table is a table that is, a table with columns, as you would normally draw a table. Each column can represent a variable, a condition, or an output. But not every variable, condition, or output needs a column in the trace table. Now, the purpose of the table is that we can run through an algorithm, we can look at an algorithm that is written down in front of us, and we can simulate what a computer could do if the program were to execute, which is the reason why in exams we get these a lot, okay? We see trace tables a lot in exams because obviously you don't have a computer in front of you in a written exam. So we complete this table to show how the variables change, what those conditions would resolve to. So if there was an equation of some sort, how that would resolve, and or what outputs would be displayed. Okay. So why do we use them? Well, there are two main reasons that we use them. Firstly, we want to determine what an algorithm does by running through it to see what happens as the algorithm runs. So you could be trying to work out what the algorithm is doing. The second reason we can use a trace table is to test the logic to see if there are errors that haven't been easily spotted the first time round when you're kind of just looking at the algorithm. So to spot logic errors, programmers will often try out programs to see if they work by dry running the program. This is a term that programmers use, dry run, which is basically means that you're going through the program without a computer, and you're working through that program a line at a time, and you're going to write down the values of each variable in a table, or otherwise known as a trace table. And you are tracing your way through the algorithm, which is why it's called a trace table. So this means you can spot how the numbers change, and you can see if there's an error of some sort. Okay, right. We've got a little bit of algorithmic fun now. So I want you to have a go at this. Choose a number between 1 and 9. Multiply it by 3, add 3, multiply it by 3 again, add those two-digit numbers together and see where you're going this weekend. making plans for this weekend, use this simple calculation to help you work out the ideal place or activity for you. If you want to post in the chat the number that you picked and the place you are going. Give you another couple of minutes on that. So you may have noticed that if you choose a number between 1 and 9, let's say, oh, I don't know, I'll choose the number 2. Multiply that by 3, okay, that's 6, add 3, that's 9, multiply by 3 again, that gives me 27, and then I add 2 and 7 together, what does that give me? That gives me 9, okay, so where am I going to end up? Oh, I'm staying at home. What you might notice is that no matter which number you pick, you will end up staying at home. It's just a little bit of a joke. It's a bit of an idea that obviously a lot of us are staying at home at the moment just because of the lockdown. It's just a bit of fun for you there. Now, I didn't see anyone post in the chat their answers for that, but you hopefully will see, no matter which one you pick, it will give you stay at home as your answer, or number 9. Okay, so we're going to go through what this means, and we're going to do this in a trace table. So what I've done is I've put this into some pseudocode for you. So the number is whatever the user has picked, so the user input if we were doing this on a computer. Then the number becomes itself times 3. Then the number becomes itself plus 3. Then the number becomes itself times 3 again. And then, yeah, and then if you have the number, make it to add the 2. So the 2, this last section here, add the 2-digit number you get together. Now, to do that in on a computer or even in an algorithm, you need to get num div 10 to get the first digit, and then num mod 10 to get the second digit. So the first digit will, so if you divide by 10 and have no remainders, which is what div means, then you'll get the first digit. And then to get the second digit, you want num mod 10, which is dividing by 10 and giving you just the remainder, not the divisible part of it. And then we output the number. Okay, so we're going to go through and we're going to create a trace table for this. So let's pick some random numbers. Let's start with We've already done 2, so let's pick a different option. Say, I don't know, 3. Let's do 3. So the user has inputted 3. Okay, now it asks for the number times 3. So number is number times 3. So I'm going to say 9. 3 times 3 is 9. And then 9 plus 3 is 12. And then 12 times 3 is 36. And then num div 10 is, I don't know which box I want to put this in. I'll put it in this one up here. Num div 10 is 3. And num mod 10 is 6. Because if you divide 36 by 10, you get the 3 remainder 6, which is why it looks like that. And then if you add them together, your output should be 9. Okay? So you can see the same idea can happen. And you can see for every line I've created here, every part of the algorithm, I've put it on a separate line. Now I could have split this line up here. I could have written this 3 and 6 on this line here, just because it's on a separate line. I might actually do that. Just gonna move these down. Okay, so you can see that every line that I've got, so the users input something, and then that number is times by 3. So actually I've done something wrong there. What I should have done is I missed something there. So I'm going to just quickly make sure I've not missed that. Obviously, the number has to be 3, doesn't it, at the beginning, because that is what the user has input. That number is 3 at the beginning. So the number becomes number times 3, gives us 9, and so on and so on. Okay, if we did it with a different number, we should still get the output of 9. Let's try it with a different number. Let's try it with 5. Number times 3 is 15. Oops, sorry. Let's put 5 here. And then 15. Add 3 is 18. Now I'm getting into maths now. 18 times 3. Dearie me, I'm bad at maths. Let's get up my calculator. 18 times 3 is 54. Okay, and then 5 and 4 added together gives us 9. Okay, so no matter which way you do this, you can see that the answer is always going to be 9. So hopefully you've been able to see that each line I've created here, I've got a new line for each part of the algorithm. Now, often we're looking at a loop, where in that loop, each part of the loop is one line. So each time we go through the loop would be one line rather than each line. But this is just a very simple example to kind of show you exactly how to do this. Okay, let's get you doing something now. So I'm going to post a link in the chat, and I'm just going to quickly show you what I expect from you. So this is going to be the link. Let me just post that in the chat. When you go there, it will ask you, would you like to make a copy of Trace Tables task? So you click make a copy, wait for it to load, and then you've got a task here. So what you'll need to do is write in all of the different bits. You can edit this because this is your this is on your user rather than mine. Okay, and this is kind of like the kind of thing you might get in an exam. So it'll give you some examples of some of the different things. So this should give you an example of something. This is an algorithm where it says total is 0, for counter is 1 to 5. Now one of the things I will make sure you know, in pseudocode, it goes 1, 2, 3, 4, 5. If we were looking at this, it's 1, 2, 3, 4, 5. Whereas in Python, if we were looking at it, it might be 0. So if it was for x in range 1, 5, it would only be 1, 2, 3, 4 because it doesn't include that final option, final value, whereas it does in pseudocode. So that's something, at least in AQA's pseudocode. So that's something you will have to bear in mind. Okay. So have a go at that. As I've said on here, once you're finished, I want you to click share and click get shareable link. So I'll show you how that looks. So click share and then get shareable link, copy link, and then there you go. Okay. So, and then I want you to paste that link into the comment section of show my homework. Okay. So have a go. I'll give you a few minutes. Okay, let me know if you have managed to finish that, but I am going to give you another few minutes just to get that finished. It shouldn't take you too much longer, but I'm going to give you another 3 minutes or so. Okay, so hopefully you've had a go at that. Just a quick overview on that. So when you click on share and then click get link and then click here, anyone with the link, and then just copy this link here, and then whatever this link is, copy that into show my homework, and then I can see whatever you have done on there. So quick little, I'm not going to do these bits because you should be able to work those out yourself, but I am going to just quickly go over a couple of these other bits, okay? So state the output if the user enters 21, 10, 5, 30, and 9. So total at the beginning is always going to be 0, so we're going to put that in first, okay? Then what's it asking for? For counter is 1 to 5, so I'm going to put in counter of 1. Then output, enter next value. I mean, I could say enter next value, okay? And then value becomes user input. So value at this point is 21, whatever the user has typed in, okay? If the value is less than 10, then this should be indented one more. And there as well, although it should have been indented, so I apologize for that. If the value is less than 10, then. So is the value less than 10? No. So we're not going to go into that if statement, going to go to the end if. You can see that I didn't necessarily need those indents because that end if showed me where that if statement actually ended, which was quite useful in that particular example. Okay, so I've got to the end of that if statement, go to the end of the for statement. Okay, let's loop back. Counter is now, was 1, is now 2. Okay, and then it says output enter next value. Just going to copy this over. Okay, then it says value becomes user input. So what's the next user input? 10. So I put 10. Okay. Is the value less than 10? Is 10 less than 10? No, it's not. So again, I don't go into that if statement. I just go to the end if, end for, and then back to the beginning. For counter is 1 to 5. Okay, counter is now 3. And my value, output enter next value. So I'm going to enter next value. Value is user input, which is 5 this time. Okay. So is 5 less than 10? Yes, it is. So new value is value divided by 10. So new value is 0.5. Okay, and we're going to output that new value. So I'm actually going to get rid of these because I don't think that's the output that they were asking for. Just going to output that 0.5. And then we've got a total, which wasn't being used before. So I'm going to add that in. Total is total plus new value. So 0, which is the current total, plus 0.5 is 0.5. Okay. So then we've got to the end of that if statement, going to the end of the for statement, back to the beginning, because we still haven't got to 5 yet. So for, what's the value going to be? Output, enter next value. Value becomes user input, which is 30. Okay, and then the new value is, if the value is less than 10, is the value less than 10? No, it's not, because it's 30. So we go to that end if, end for, back to the for counter 1 to 5. Okay, so I've got one more to do, and then 9. So it's going to say value is user input, which is 9, and then new value is 0.9. Okay, and then it's outputting 0.9. And actually it's going to output one more line, so we really need one extra line here, which for whatever reason that wasn't in there. I'm going to insert another row. So total becomes total plus new value, so the new value is 0.9, the total at the moment is 0.5. 0.5 plus 0.9 is 1.4, isn't it? And then we've done our for loop because it's gone 1 to 5. We go to output total, which total is 1.4. So we put that over here. Okay, so hopefully you can kind of see what's going on here, right? And again, I expect you to be able to complete the rest of that yourself. Once you have finished, please click share, click on get link, and then make sure this says anyone with a link, and copy this and put that into the show my homework. No matter if you're watching this now or watching this later, it would be good to have that from you, and then I will give you a contribution to the lesson point. Okay, so moving on. I want us to look at this program as well to work out some average scores for a student over 4 tests. So we've got total score is 0. It says 4 count becomes 0 to 3. And don't forget, in pseudocode, we're including that last value, whereas in Python we wouldn't normally. Next score becomes user input. Total score becomes the total score plus the next score. Average becomes total score divided by count, and then it says output average is plus average. Okay, so Arnold Adams had scores of 21, 15, 14, and 24. So the teacher expected the average to come out as 21, but the answer given was 28. So this is where the use of trace tables can be really useful, because we are then able to look at what the problem might have been. So we're just going to do this with my camera here. So you can see I've already put in place the different items. So we're starting with total score is equal to 0. So I'm going to put that in. Total score is equal to 0. Okay. And it says 4 count is 0 to 3. So count is going to start at 0. Okay. And then it says next score is user input. So the user input, as it's mentioned at the bottom here, is 21. So I'm going to make that 21. And then it says total score becomes total score plus next score. So what's the total score at the moment? 0 plus next score is 21. 21 over here. Okay. And then we go back to the beginning of the loop because we haven't finished yet. So it's 0 to 3, so 1. Next score is user input, which, as it says down here, is 25. Okay, and then it says total score. Ooh, again, I'm not quite got it there. Total score is total score plus next score. So total score plus next score, 25 plus 21 is 46. Okay. Then again, we still haven't gotten to 3, so we're going to go back up that for loop. 4 count 0 to 3, so it's now 2. Next score is user input. What's the user input? It's going to be 14. Okay. Then total score becomes total score plus next score. So 46 plus 14 is 60. Okay. So then again, we go back to the beginning of our loop. Is that count 3 yet? No, it's not. So we're going to put in 3. Again, in pseudocode, that is how that works. So when it says 0 to 3, that will count 0, 1, 2, 3. Next score is equal to user input, which is going to be 24. And then total score is equal to total score plus next score. So 60 plus 24 is 84. Okay. So now we're out of the loop because we don't need to go back to the beginning of that 4. We can just continue from there. So average becomes total score divided by count. So it says total score, which is 84, divided by 3. So 84 divided by 3. You could do a quick little calculation there. Let's just do it on my calculator. 84 divided by 3 is 28. Okay, so average, it says 28 is our average, which that's not quite right, is it? The average of 21. So if we were to do this manually and say 21 plus 25 plus 14 plus 24, how many, and then add them all together, That still gives us 84, so that should come out correctly. But we should actually be dividing it by 4, shouldn't we? To give us our value of 21, because there are 4 values here, not 3. So the issue that we've got here is that we're counting from 0 instead of counting from 1. And we're counting up to 3 instead of counting up to 4. So the way we can fix this is, instead of writing 0 to 3 up here, we could write 1 to 4. That would be the way that we could fix that problem. Okay, so hopefully you can see from that idea that that if you create a trace table, you can, I mean, it doesn't look completely out of the question that you would do it like this, but when you run it, it makes a lot more sense that you've got 4 items. I mean, even if we were to do this in Python, and you were to say count is equal to 4 count in range 4, then it would give you the same value as 28 instead of 21, 21 instead of 28 instead of 21, because that value goes up to starts from 0 and ends at 3. So that's one of the issues that you might have in Python. Okay, so I'm hoping that that sort of live version of the thing allows you to kind of see what I'm talking about. I would like you now, I've got another link that you've got, and I want you to try and complete the next 3 questions. So the first 3 questions, sorry, not the next 3. And so this is a little workbook for you to complete. So I want, again, the same idea as before, completed questions 1 to 3, and then hopefully you'll be able to come back and we'll kind of make the next bit of the lesson. Okay. Okay, so hopefully you've been able to complete questions 1 to 3. Just before we move on to the next part of the workbook, I just want to show you the idea. I'm sure some of you have kind of thought, I would like to be able to create, think about tracing my algorithms when I am writing code in Python. In Python, obviously, if you're using IDEs such as Thonny, that would give you a way of being able to debug your code. But sometimes actually printing out what your code is doing, what the different values of your code are while you're running it, is one of the quickest ways to be able to tell what's going wrong with it. So here's an example of how you could create a trace table in Python. Now, you can use a tab key by writing \t inside a string. In answer to Kennedy's question, yes, you can get access to Thonny at home. You just need to Google for Thonny, Thonny, and then you should be able to just download it. As long as you've got access to be able to download things at home, then absolutely you can access it at home. So being able to use a tab, you're using that \t, a bit like our \n, which denotes a new line. \t just means this tab space, so which is the button that's above the caps lock. It's how we add our indentations into our code. So that gap there is a tab. So \t allows you to write that in programmatically. So you can see here, num \t, index \t, number \t. So that allows us to have this gap here, okay, which makes it a lot nicer to look at it as a table, okay. Now I've commented out this print answer because that's what I'm going to have my output be. But every time, if I print answer every time, it would appear between every one of these lines, which would be an issue. So I would just comment out any extra print statements you have going on, just so you can see the whole table and it's a lot easier to see. And then you just put the names of your variables, whatever variables you want to check. So the number, the index, so I in this case, the number that you've got, so answer, and the output, which is also going to be answer in this case, so because we're printing out answer. If that was something different, it was printing out, you would just put that there instead. So inside that loop, all the variables being traced are concatenated. So 6 tab 1 tab 6 tab 6, etc. And that allows you to line up these quite nicely. Those spaces line up with the headings. Okay, so I'm going to just give you pretty much the rest of this lesson to complete that booklet as much as you can. Once you're finished, don't forget to click on share. Make sure you click on get shareable link, paste that link into the comment section of show my homework, and then I'll give you that excellent work thing when I can see that it's a completed booklet, or mostly completed booklet at least. Okay, so if you've managed to complete and send that task, you get that excellent work point. Okay, so again, up to 3 points up for grabs this lesson. 1 for the first, 1 for showing up on time, 1 for doing the first trace tables, the trace tables task, and 1 for doing the trace tables workbook or booklet. Okay, so excellent work points go to those students who have managed to complete and send me the task. Okay, going to give you pretty much to the end of the lesson. I'm just going to play one song, and then you can complete this in your own time. But I am then going to just round up the lesson so that you can see remind yourself what it was that we were doing this lesson. Okay, so a reminder that when you are sharing your links, in order to make sure I can see it, because you won't be able to have the link shared properly unless I can see it. So you click on share, make sure you click on get link, and then make sure this is selected, anyone with the link. If you have already sent me the link, just make sure that this has been selected, because otherwise I can't see it. Okay, make sure that's the case. So once, even if you send me the link and you haven't quite finished it yet, I will be able to see any changes you make in the future. It isn't a link of seeing what you've done and that's it. If you make any changes, then they get saved to that link as well. So to round off the lesson, I just wanted to remind you of what we've been talking about. We've been going over the idea of trace tables and trying to make sure, that that you can use trace tables and visual inspection. So when I say visual inspection, that means to look at an algorithm and try and figure out what it's doing. So using trace tables to figure out how they work, visual inspection as well, to figure out what their purpose is, and to fix any errors that may have occurred, to try and figure out where those errors are and to fix those errors. Okay, so please finish off any of those booklets or those tasks that I've given you. If you have any particular questions, feel free to ask me on Show My Homework. I know that today not everyone's been able to make the live stream, so please make sure you catch up another time so that you can learn about these, because trace tables are, as I've already mentioned, something that comes up, that will definitely come up in your exam. So you will want to make sure you understand how to do these. Okay. Right. Have a lovely weekend. I apologize again for having done this on a bank holiday. I again completely forgot that it was going to be a bank holiday, and by the time I realized, it was silly to have cancelled, because otherwise it would have been very last minute to be cancelling it. So as I say, have a nice weekend. I will speak to you again on Wednesday. And I apologize for not putting up the points for last lesson. I've been a bit lazy this week, to be honest. So yeah, do keep pestering me about those, because I keep forgetting to put them up. I will endeavour to do those now. So again, have a lovely weekend. See you Wednesday. Bye.